if it were me and I was designing stairs, I think I would base it on the inside unit run. And then in the last couple versions here, it is based on steepest by code. I'll just slap that into place. There we go. Oop. So let's just see what this looks like when you are given the inside unit run. I'm going to bring this up again too. This is, maybe know how I can get rid of that black thing. So oh, there it goes. All right, so let's have just a quick peek at the building code in this respect. Now this is dimensions of tapered treads, which is exactly what a circular stair is. It's a series of tapered treads. Tapered treads shall have a run that is not less than 150 at the narrow end of the tread. And so there you go, minimum unit run for a circular stair. Actually, I shouldn't even say circular stair. I should say a tapered tread is 150 millimeters. And it complies with the dimensions stated in table 9842, which is right up here. When measured at a point 300 millimeters from the center line of the handrail at the narrow end of the tread. And in our theory modules, remember we chatted about this? I was going on about this. Your unit run has to comply with this table. And this table is the table for rectangular treads, minimum and maximum unit run. But they say that this table also must conform, or the stair, the taper tread, must conform to this table at a point 300 millimeters from the center line of the handrail. So we're going to look at this in a minute too, but let's get back to doing this calculation and see how that all fleshes out. Trying to maximize my screen space here. Is anybody looking at this on an iPhone 4? That'd be funny. Number of risers and unit rise. Total rise of the stair is 2840. I mean, we always have to do the same thing at the outset, divided by 185. 2840. I'd like to glance at my calculator when I'm doing these, when I'm inputting the numbers. Anybody else do that? Getting 15.4. And it is as close to 185 as possible. So I'm going to go 2840 divided by 15. I mean, has anybody ever made a mistake by typing in something incorrectly? And then you're like, how did that even happen? 189.3 I'm getting. Number of treads, we've got 15 risers, so I've got 15 minus 1, 14 treads. Wow, this chair is so squeaky, very irritating. Headroom was 2085. Plus the upper floor thickness of 330. 2415. DTLF 2415. Do you feel like you're getting your money's worth for entertainment today? I hope so. 230 unit run at the inside stringer. And so this is the inside. Oh, I better turn to red. And unit run is 230. So, you know, we've sort of needed this stuff and this stuff in order to head down the road here. So how is it that we can go backwards on this? Well, if we know our unit run of 230, I'm going to get rid of that. That's just now distracting me. I've got my unit run of 230. I know that I have 14 treads. So I'm going to go up like this. 230 times 14. 3220. Essentially what that number is, it's the distance from here all the way around to here. But we don't have any information to draw any proportions or calculations with yet. We have nothing to go downwards or downhill on this thing. So we're going to have to cough up the circumference of the inside. How would you go from this partial circumference to the full-on circumference?
That'd just be a direct proportion using the 120 and 360, wouldn't it?
Precisely. It's just as it was going downwards, but in this case, we're going upwards. And we happen to know that that run is 3220, which is the 120 degrees. I'm pulling that off of this sheet here. And so therefore, I'm going to pop that number up here. And now when I do this, I'm going to end up with my total circumference down here. And you can see that the relationship between the stair and the full circle is a 1-to-3 relationship, right? And so it's going to be 3220 times 3. Do you see that as well? I'm not trying to mess with your heads here or anything. I mean, I can do the full calculation, but it's going to be 3220 times 3. 9660. And now we have something to compare some of the other things with. So now we can head downhill here again, strangely. I'm going to drop some things in here. 1, 2, 3. And now I'm going to drop number 4 in there. Let's see. Do we have enough? Yeah, we don't need this number up here at the moment anyway. We're going to use it later, but we don't need it at the moment. So let's come down here and do this. And remember what this guy was? Unit rise over unit run is equal to drop to line of flight over finish opening. Golly, that's easy. Geez. Unit rise 189.3 over unit run of 230 equal to drop to line of flight. We calculated that earlier to be 2415. And now I'm going to hash that out here. What do we got in my calculator? Nothing useful. 230 times 2415 divided by 189.3. 2934. 2934. 2934.2. And this bad boy here, finished opening in degrees. And so what we have here, finished opening, this is the distance. Green line. Let's do a green line. Finished opening is the distance from here around here. So let's do that. Finished opening in degrees. So remember we were using the full circumference to draw some proportions. So 360 degrees is equal to a full circumference of 9660. Sometimes it's bad using a fat pen. And this is the finished opening, which is going to give us this degree, direct proportion, 2934.2. That's just hanging out in my calculator here, so I'm going to use it. Times 360 divided by 9660. 109.4. It's ever so slightly different than what our sheet says, hey? That's okay. I'm a reasonable person if you are out by, 0.1, 0.2 degrees. That is totally fine by me. So we got this, got that. We don't have that yet. Radius, don't have that yet. Unit run at the outside, oh wow, we just almost don't have anything yet. We sort of subverted the whole thing. How are we going to go from 4, let's see here, 5. Let's go up here now and do this guy. How are we going to go to radius from here. Oh, let's see here. We have circumference, 9660. And if we divide it by 2 pi, we should get r. Nice. 2 pi. I'm tired of writing 6.2832. So now I'm going to pi. 9660 divided by 32. 1537.4. Plus, oh, look, we got it. Nice. Plus the width of the stair, 1200. The more you do this, the more you realize that you can just keep using numbers in your calculator. 2737.4. 2737.4 is the outside circle radius. And then I'm going to take that, multiply it by 2 pi. See, now we're going downhill again, and it's just like the first problem. $17,199.8. And then we do, that's the full circumference. The full circumference is indeed 360 degrees, 17199.8. Are you guys on campus this afternoon? Is that what's going on? Not today. So,
No, there's just no time to get the COVID test on, if that's what you're talking about.
yeah.
There's no time to do it on Tuesdays.
It's 120 equals divided by 360 equals 5733.3. Change color because that's important to all of us. 5733.3, I guess, is the total run. That's the outside. Scooby-Dooby-Doo. Whoops. All the way around like that. Total run. Now the unit run is going to be 5733.3 divided by number of treads. That is 14. Divided by 14, 409.5. And now finished opening. Unit rise over unit run is equal to drop to line of flight over finished opening. You can see here now just by looking at this, you just have to keep in mind that inside and outside has to be separated all the way through. I think that's where students make most of their errors. Finished opening. Drop to line of flight 2415. And that'll cough up a nice number here. What do I got in my calculator? 409 times 2415 divided by 189.3, 9.3. 5224.5. Double checking, looks good. That's our finished opening, which is from here all the way around to here. And just in a straight stair, we're just going to draw some proportions here. So 360 is our full circumference, which was 17199.8. We're trying to solve for this bad boy here. We're going to use the finished opening 5224.5. Times 360 equals divided by 17199.8 equals 109.4. Thank goodness that came out to the correct number. 109.4. Radius of the outside, got it. Unit run at the outside, got it. Degrees turned by 1 tread. The stair turns 120 degrees. I've got 14 treads. I'm willing to bet that that's going to be 8.6. Insofar as I am even going to not even calculate that. So there you go. That was, it was at a certain point, it just started looking like the first problem. It's just that you have to realize you got to go backwards. When you start at your unit run, you have to sort of go backwards a little bit to get some of the information you need to go forwards. You know what I mean? Sort of. So that's not too painful. Let's go down to this guy, steepest by code. And let's see what information they give us here. Blue, 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 blue. Use code max rise and minimum run. So what would that be for a residential house? What is max rise? Nobody wants to put it out there? Thanks, Charles. Max rise, 200. And as I was blabbing on earlier, the minimum run, max rise, min run for a tapered tread is 150. So on the inside of a circular stair on the inside stringer, is the slope above or below 45 degrees?
It's above.
That's right. It's above because your run's 150, your rise is 200. And wow, you could get up that stair super quick if you could walk right there. But I don't know about your feet. My feet aren't that big, but. So that's essentially the rest of this. All you have to do then is say, do all your calculations. And same thing here. I'm going to drop it in here. For your unit run, that's going to be 150. And all of your calculations up here, max rise, you're going to be going, let's see, in this case, 2850 divided by the max rise of 200. You know what, just for kicks, let's work that out. 2850 divided by 200. It says 14.3. This is perfect. Which way are we going to round that number? This bad boy has to go up. Must go up, because if you were to go down with that guy, you'd end up with a unit rise higher than 200, which is unacceptable. Very unacceptable. I'm going to go back here. I want to go back to the first one again. This is it here. And I just want to hash out a few numbers. Let me just clear that up a little bit. I want to talk about the unit run, and I'm going to have to zoom in a little more. And I want to talk about the building code in the context of this problem now. And I'm going to draw in a handrail. Holy, don't build your handrails like this, by the way. I guess I have to go all the way now. I've started. How tragic. I can see some sunlight through the layers of my handrail. Anyway, this is the upper floor, so this will be going down. Not that it matters. in the context of this question, what is the unit run 300 millimeters from the center line of the handrail? So I'm going to need to tell you some stuff. I'm going to have to tell you that the handrail is, let's say it's 50 from the wall, and it has a 50 diameter size to it. So now the question is, what is the unit run? And I'm going to come back to the code here now. Zoom, zoom, zoom. How do can I do this? Complies with the dimensions stated in table 9842 when measured at the point 300 from the center line of the handrail at the narrow end of the tread. How would we ever check to make sure that our stair, which we just did all these calculations for, actually complied to the building code? And realize that our spread is 255 to 355. Okay, let's go back. 255 to 355. What is the unit run at 300? Blah, blah, blah. You know what I'm talking about. From the center line of this handrail, 300. We want to check. We want to double check and make sure that this unit run is within the parameters of these two numbers. Okay, so Kyle says radius plus 375. Just off the top of my head, that sounds correct. Let's give that a go. Inside radius was 1200. That's 12. The space was 50, I said, and the diameter is 50, so that's 75, so that's good. I like that. So let's go 1275. And what do I do with that? Now what? So it was 12. Sorry, I'm going to come like this. It's 1275 to there. I add the 300. I end up with 1575. Now 1575 to this. I guess we'll call it a walking line. I'm kind of reluctant to call it that, but let's call it the walking line. So it's 1575. Now what?
Get your circumference.
Okay, let's see. Let's go 1575 times 2 pi. (9896.0). 896.0. Did you hear me call it 0.0? When I was up at the wood guy place, Gary, he said, oh, so I was buying the stuff at the end, and Gary says, what's your phone number? So I go 403, and he repeats it back to me, 403. Do you notice the subtle difference there? He was like very precise, very precise. It wasn't 403, it was 403. So he repeats it back as a number, not a letter. Anyway, now what do we do with this bad boy here? So we've got the circumference at this point. Now what?
Do your portion of that as a portion of the circle for your degrees. So
something like this, Charles.
Multiply by 135, yeah, divide by 360. Gives you your total run.
If you had the degree of each tread, could you not use that 9.6 or whatever it was, and then just get the run of each tread at that point, just to kind of cut out this 135?
Maybe I'm gonna have to mull that over. I feel like there is a path that way, but I'm not going to follow it right now. I'm going to follow it later. But Jared, I feel like there's some validity to that. So this is our stair angle, right? This is not our finished opening. This is our stair angle. And so we come up with this number. And now we say, because essentially what this is, I want to stop saying essentially, but actually what that is, it's the length of this line all the way around here. Now I'm going to have to divide it by the number of treads, 3711, divided by 14. And I come up with 265.1. So yay, for us, it falls in line with these two numbers in here. It falls in line, so we're good to go. This is good. And now Jared is saying, hey, we know the degrees turned by one tread. So what does that mean out here? Out here in the boonies. So this is 9.6. I think if I was to do this calculation, I might find out exactly what that angle was, to maybe 3 or 4 decimal places.
Yeah, I just ran it, and it comes out to 263.9 if you do it with just that whittled down 9.6. So it's not as accurate. But I guess, yeah, if you kept that decimal point on the degree, it would be exact, right?
Yeah. The other thing, Jared, that I'm seeing right now is when we do that little trigonometry trick, we actually find out the chord length across here, not the arc length. And I mean, this is a super negligible amount, but just having to say that when we do that little trick where we take this and we half it, right? And then we know this radius because it's equal to the hypotenuse or whatever. And we know that this is now 9.6 divided by 2. We're actually figuring out the chord length, not the arc length. And the building code.
I wasn't doing the trigonometry of that. I was just using the 9.6 degrees in lieu of 135. Because 135 divided by 14 would be your 9.6, right? It was just cutting a step out kind of thing.
Yeah, I got you. And then you, did you run that 9.6? Like, what's that actually? 135 divided by 14, yeah. Yeah, that's huge.
Yeah, 9.64. So you could do that times 9896 divided by 360. Yeah, 265.07.
Yeah, so we're there. Like it's 100. It works totally fine. I guess the only reason I went this route is because it's familiar to us now in the regular way that we do things, but certainly you can do it either way. Here we go. So there's always that sort of beginning business. Total rise 2690. So I'll divide by 195 because that's what it says to do. Uh-oh, where's my calculator? I got it. 2690 divided by 195 is 13.8. And so I'm going to have to go 14 on that, just because that's the proper direction. It says plus or minus. So I would round this to the nearest. If this had said 13.4 and I rounded down, then I'd probably end up with a greater than 200 rise. So I'm definitely not going to go that direction. So 2690 divided by 14. And don't forget that we are always using finish floor to finish floor. I feel like in the IP, they'll give you all the data for the question, but then they won't give you the total finished rise. So make sure you are aware of that. So we got that guy and that guy. And now it's sort of like, oh yeah, drop to line of flight. I'm going to need that guy one way or another. And they are 2085, which is headroom plus floor thickness. Upper floor is 290. I'm getting 2375. Sounds about right. So that's my beginning. And now watch this. I'm actually going to show you the thing, the little flow chart here. And when I look at this first box, I see radius. And when I look at the second box, I see 2 pi radius. So I feel like I can group those together. Just this is only for the purposes of remembering this little flow chart. And then in the third box, I see total run. And in the fourth box, I see unit run. So those are easy to remember. Radius, 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 circumference, total run, unit run. And then down here, we've got FO. And then the ultimate answer, actually, which is finished opening in degrees. So those are the three sort of boxes. And when you categorize things like this, I feel like they're easier to remember. And I mean, if you use this flowchart in your test, I'm never going to know. And if it helps you finish the IP or pass the IP, it is a win for both of us. So now if I go up here and I have remembered that thing, then I know that I have to look for the unit run at the inside. So, and then remember that I have inside on one side of this thing, and I have outside on the other side of this thing. So what do we need to do first? What's happening? What should I do first?
Can you zoom in a little bit, please?
What other things do I know? Well, I know the stairs are a certain width. They turn 120 degrees. Inside stringer has a radius of 1350. I've already used this number. I've already used that one. I've already used that one. I've already used this one. 1350 wide stairs. That only comes into play when I'm going, you know, from this direction to that direction.
Yeah, so take the inside stringer radius, 1350, or times pi times 2.
And I'm getting 8482.3.
Okay, and so add 1350 plus 1350 is 2700 times pi times 2 for the other side. Or do you work down one side and then work down the other at the?
Yeah, it doesn't matter actually. So we can go that, oops. 1350 plus 1350. Probably easier for us just to stick to one side for now, 2700. What was our little memory deal down here? Radius, circumference, total rise, unit rise. So there's radius, there's circumference, total rise, total run, I should say, sorry, total run. What are we going to do here?
Is that not the common difference? Like
Well,
120
it's,
over 360?
Yeah, that's the one.
Yeah.
But it's like a proportion thing, not so much a common difference. And we worked out our 360 degrees was 84823. So it's actually a third, because just because I know that I can see that 120 is a third of 360. 28, 27, 4.
And then divide that 28, 27 divided by 14, right?
That's right, 28, 27.4, just like in a real straight stair. Is it 14 though, actually?
Maybe 13.
Yeah, number of treads. $217.5. So we had total run. Now we've got unit run. And then the next thing in our little memory deal was the finished opening. Remember, it was finished opening, and then it was finished opening in degrees. So what's the finished opening formula again?
Drop the... Oh. Yeah, I don't know. Never mind.
It was the drop to line of flight and the unit rise, unit run at the inside and outside as a direct proportion, wasn't it?
Yeah. So as long as you don't swap sides here, then you're good to go. So unit rise over unit run is equal to drop to line of flight over finished opening. And by the way, guys, all you need is any three of these to figure out the fourth thing. And the reason I comment on that is I've had students tell me about an IP exam question where you get the run of the stairs and you're supposed to calculate unit run from that. So they give you the run of the stairs. This is looking kind of nasty. That is one thick stringer. Anyway, they give you a bunch of info. For example, they give you drop to line of flight. And they give you, I think in this question, they give you rough opening or something like that. And as long as you have unit rise or unit run, you can calculate one or the other. That's the idea behind this. Actually, this would be finished opening. Finished opening, drop to line of flight. And if you have either unit rise or unit run, and unit rise can be calculated by going like this, taking your total rise and dividing by some sort of desired thing, or maybe the question has the unit rise given to you already, something to that effect.
Or like max code or min code or something like that, right?
Something like that, but it has to be a calculated amount, like it has to be exact. So either you have to calculate it or they have to give it to you. Okay, but in this problem then, whoops, let's pop the numbers in there, actually. So it's unit rise, which we calculated earlier to be 192.1, and unit run, which we just calculated to be 217.5, and the DTLF, which we calculated from the outside there, the beginning, 2375. And do you see also the relationship between these guys? You know, it's a vertical number compared to a vertical number, right? And then this finished opening is a horizontal number, just like the 217.5 is. That's why this whole thing works.
Oh,
So
that's a good thing to remember for sure. I wouldn't have thought of it like that. So, like even when you're like calculating like unequal slope roofs and stuff, you got to make sure that you lay them out like that, right? Like vertical to vertical and horizontal to horizontal.
That's exactly right.
Okay.
$2689.0 is what I'm getting for a finished opening on this guy. And then we want to figure out the finished opening in degrees. And you can either use the inside or outside for that, doesn't matter. But since we're here anyway, and this step is similar to this step in that we are comparing it to the full circle. I think the module shows you two different ways to do it. I've always found this way to be a better. Guys seem to understand it better. So the 360 is the full circle, 8482.3. 8482.3 is the full circle. And we're trying to calculate the angle, which is sitting up here. And we just calculated the finished opening. So 2689.0. And that's still floating around in my calculator. So I'll go times 360 equals divided by 8482.3 equals 114.1.
Yeah, so like you're wrong if it's definitely like if it's over whatever that they say like the 120, you can definitely see it's got to be less than that, obviously.
Yeah, and it should be just barely so less. Otherwise, the stair is probably not going to work.
Because you won't have the headroom clearance.
Yeah, exactly. And then, of course, the outside is done in exactly the same way. It's just that people sometimes, like once you start heading down this way, you don't cross. There's no crossing here. It's like a red line. You don't cross over with any of the numbers. You have to keep going down in this direction.